Hi. So this episode took a lot of time from my side. So I had to learn a little bit about YOLO, what is neural network, how can I train a model with YOLO. But why I'm interested because I would like to compare the traditional methods of object detection such as HAR cascade, which use XML files, or HARC descriptor. Um, Instead of that, because in one video that you probably have seen it in my podcast, I try to compare HARC descriptor and HARC cascade, and the result was more satisfactory with HARC descriptor rather than HARC cascade. And this time I actually use YOLO V8 version 8 to train a model. So for that I had to use or make a database and try to train or do annotation and labeling for the object that I would like to detect, which now is basically human detection, and try to basically label it and then make the local basically data set and use my own laptop computer and use the Raspberry Pi camera to take the images that I wanted and train those images, and then I used again the live webcam camera and evaluated that model. So in this episode, I would like to go through step by step what I have done, how could I create basically a model, and what was the result of that training, how long it took from my side, and then we will evaluate in real live camera what was the result. So yeah, so I think you will enjoy it. So and let's do it together. So first thing first, we need data, right? Before training anything, we need pure data. So I have taken a lot of images from myself inside the room over a couple of days. So something like 800 until or maybe 1000 pictures. And I will show you, like, this is the pictures that I've taken. So as you see, I don't know, this is one. And so a lot of pictures when it was dark, when the illumination was better, when it was a daytime. So really different type of photos. And basically I was sitting on the ground, on the floor, I was sleeping on the bed, I was with my girlfriend. So anyway, so it was like totally different like perspective of me inside the room. So this was the first step, that I actually took a lot of photos. And yeah, so basically I made the data set that I needed. But the second step was that I had to somehow do annotation. For that purpose, basically I've used a website that on this website you can basically annotate your images or your data set. So there are different really tools to do the annotation for the images, but this one, maybe I can show you. This one so-called CVAT, and you can basically go and create a project and define a new project, for example task 1, or I don't know, task 3, for example, as a name, and then add a label, and then you define a label like I don't know, human, and then you define a color, and then yeah, so you put submit and open, and you have created a project. And then after that you need to basically edit your project, right? You can, as I said, add a label. Of course, I don't know if I created like label human, and continue. So you have created now, and you can go edit. No, sorry. Can go back to the project, and here you can create a task. Yes, you can create a new task like I don't know, task human annotation, and then this belongs to the project task 3, and then you can insert all those files that you have created basically. Then you don't need basically to upload all these files like of course when you give more data, of course it's better, but you can select these files, for example, and upload that, and then when it is over, you can submit and basically open. So when it goes after submitting, like you can start basically do the annotation on this website. I will show you now a video, some pictures, of course, that's how I have done this annotation, right? So I guess it was somewhere here that I have so yes, so this is when you open this task after that you have uploaded, you can go and grab and define basically your favorite object, which is in my case is myself as a human being, and trying to basically define this rectangle, the position of myself in different location. So step by step, a very simple task, and you can basically define this rectangle from top to bottom. You don't need always to be accurately include everything, of course, but when it covers the whole body, it's much better. So that's the reason that I was a little bit always cautious that I include most part of the body. So this is something that you can do, and when you are done, when you have basically done this task, because so when you have you have uploaded the photos, like for example 24 frame counts, you can start basically you can click on the job, and then as I said, you can start to you can just start this tool and annotate that things. So basically now we have one human here and one human there, so two human beings there. And when you're finished, when everything you have basically finished the job, you can go back to the task. Yeah, I need to save it. You go to the task, and you have like this one, which was the last one, and then you have to click like here, export task data set. You come here, select YOLO 1.1, and then click OK. So in this way you can go and see that the process. So this CV80 is one of the most user-friendly ways that you can actually annotate. There are other tools like, I don't know, scalable.ai, or there are a lot of tools available, but this one is actually free and it's very user-friendly. I recommend it if you want to use it. So after that you have export this annotation, you have to go and okay, this is a zip file such like this task annotation human, like you go and open and you see this files, basically object train data, and you see that all those images that you have included have a text file. Yeah, this one I mean. So you have this basically numbers basically is 0. This, I have only one class, it's basically human, and then you have basically x and y, which is the center of this rectangle, and this one is the width, and this one is the height of the rectangle. So you have basically the center of this object that you have actually detected. So these are basically the annotated data that you have created basically based on the images that you had. So these are trained data. So but for our project we need to basically create two folder, and by this folder I mean that you need to by this folder you need basically create these two folders because it's necessary. I have created one here, I guess it was in servo lamp here. So in data, so basically this is the like address of on Windows, and you have to create two folder, images and labels, and images train, and then all those basically images that you would like to train should come here, and labels basically they also will be produced or will be created basically here. So this is the way. So you have to, as I said, copy all those images that you have in this folder, and from that file that CVA the file the website CVAT, I guess, exported, you copy everything in these labels and trains, so everything here. So when you have created that, then we need to go to our Python script, and okay, so here this is interesting. So this is the file that I actually use to take a lot of basically images from my camera, right? So this will put as well in my website. And then after you have taken a lot of data by the camera, and you have to train a model. So in Yolo basically before this one here, so in Yolo you have to, from Ultralatix, import Yolo, and the model you have to load a model. So for this one we use Yolo 8 nano .yaml. This is the format for Yolo apparently, and then you have to use the model results equal to model.train data config.yaml and epochs. So basically that's it. That's not really complicated. And then you have to create a config YAML file to define the path of the images that you have. So it should be for me is the Windows, so it should be like something like this for the Windows. And then you have to say that the train basically images / train, because the images are basically in the train. And then for validation also images / train. We use exactly the same images for the validation as well. So we have one classes as a human, which is 0. So when you have all these things, you basically, whatever you need to do is that just run this model, right? So I will run this model, and you will see that this starts to basically work on that and create a model or train that model, right? So when it is over, because it's just one epoch, it doesn't take that much time. But when you would like to train it for more epochs, it would takes a lot of time. One thing that I would like to tell you, if you are planning to use more epochs, like more training, so don't use your CPU instead of GPU. It's always better to use GPUs, and for that you have to just at the end of epochs equals 1, which you see here. You have to, I think you have to write defaults equal 1 or device equal 1. I will tell you later what was the command, because in this way you can use your GPU instead of your CPU. But anyway, let's wait a couple of seconds more until we are finished. All right, now you say that the results are saved to runs. It takes train number 6. For this I need to go to train number 6. Here I will try to open it in basically Explorer, and you see that we have the train number 6. All right, here there are some information that could be useful for us. So these are the labels that we have used in our experiment. So you see these are the labels that actually define as a human, as the only class that I have. And then I have this I think prediction, which you see that in the prediction mode nothing was really predicted, so it couldn't really predict anything. And the reason is that because I just did it for very shallow training, and that was, if you look in the results, you see that the results is just 1 point, which is basically we did nothing. So that's why for that, if you want really to train your model, if you have a good quality of photos, then you have to go and change these epochs to 100. So when you have 100 and you run this model, and as I said, you have to actually change this something. What was that? I think it was device equal 1. Because default is basically on CPU. I will write probably this in my weblog for the podcast, and that's what is exactly the term that you can use GPU instead of CPU. But anyway, when you do it 100 times, I have done it and it takes 3 hours. So we will go directly to the train. I will show you the results, how it was. So if you go to train 5, you see that this, as I said, this was like the label, as we talked. This is the label, and this one is the predictions, and you see that the prediction is very accurate. It is not like human like 90% basically accuracy, and this is very satisfactory because I see my model is actually working, right? And now I have my weights, and my weights is now here as last.pt and best.pt. So both of the models I can use. Okay, now I have trained my model. I have my model in the weights, and I have in the results I can also see that everything is going down, because we know that when it goes down we are going to the right direction. If it go high, then we have a problem. So this is good. The work validation goes down, or this loss function basically goes down. So now we have our model. Now what I want to do, I want to test my camera and see in live how satisfactory is this model. So for that I wrote this file Yolo Live Cam, that I'm going to show you how can I see mainstream images, live images, and apply my basically model that I've created so far, and then look how effective and good is that. So for that my Raspberry camera is actually live. I just apply and see the results. So I will run this one and we will see it together how good is that? It's really all right. Okay, so I'm being detected as 89%, and there is something here beside me. As you see, this is the pillow. It is also somehow because I have trained something when I was sleeping, so but I think it is much more satisfactory than the hog and hard cascade. I try to move around in this room and you will see how stable is actually this system is. Hey guys, this is incredible because honestly, um, beside this one, which is basically false, this pillow that's considered, I can remove it and we will see that when I remove this pillow, it is probably going away because it's probably thinks that it's a human being. But when this pillow goes away, I mean, like, it is now clear to me that whatever we do, basically, it really depends on the data. When I get more and bigger data set with more picture, the model can be trained much more efficient with much less error. And if I compare this with Hug descriptor and Hard Cascade, this is another level. Seriously, this is very accurate, very solid, and with a lot of like, you know, it really more stable even with darker illumination in the room, so you don't really have to apply a lot of basically light to be detected, to get detected. So I'm really happy, and this is very satisfactory because now I don't need for my robot project or servo lamp project that you see that's behind me, um, to use actually two cameras from side to side to somehow make this detection stable. So I can use only one camera at the right corner and trying to connect these robots basically from only one angle of view. So I think it's really I'm really happy. I will use this system, and I will use and will connect to my robot for motion detection and recognizing where I've been located inside the room. All right. I hope that you enjoyed this episode. I will put all these scripts in my weblog and we will write about that, and also write how we can use your GPU instead of your CPU. And I hope you enjoyed that. And please subscribe to my channel, give likes, comments, and let me know what you think, because it's a lot of positive energy that you can only give to me through commenting and subscribing and giving me just positive energy. I really appreciate that, and see you later. Okay, see you next time. Bye bye.